All right, so now that we have our masterpieces drawn, let's go through some potential questions. Something like, is oxygen necessary for the Krebs cycle and glycolysis to take place? Do you see oxygen as a substrate anywhere up here? No. The only reason that we breathe oxygen is to have it as that final electron acceptor, happens to be the last step of that electron transport chain. Another question, is there any carbon dioxide that is produced by glycolysis? When you look back up here, the original glucose molecule that would have 6 carbons is going to end up as 2 molecules of pyruvic acid. Has any CO2 been produced in glycolysis? No. It's only when that pyruvic acid goes through the Krebs cycle or chop chop that now the carbon backbone is completely harvested of all hydrogen, and that carbon dioxide will be excreted as waste. There's another question. What if there are no empty NAD molecules? Will this process start? So what if there are no empty trucks or NAD carrier molecules? Will glycolysis start? No. For an assembly line process with multiple steps to start, every tool that is required in that assembly line or that multiple step is going to be required, otherwise that process will stop. I also think of metabolism like cooking and a recipe. Recipes do have multiple steps that require different tools with different ingredients at each step. If one of those ingredients or one of those tools is missing, the final end product will not get made. So wherever that tool or ingredient is missing, that process will stop. Try it out when you're cooking tonight. All right, another question. Is the majority of ATP produced by the Krebs cycle? No, I think the Krebs cycle gets way too much credit. Only 2 ATP, and even that is a little bit of a lie because it is GTP. It does work similarly to ATP. That's why I have tried to simplify it here. Another question. Will the electron transport chain work if NADH is not embedded in a membrane? So does that enzyme need to be NADH dehydrogenase? Does that enzyme need to be embedded in a membrane? I'm hoping that you are answering yes. Why does that enzyme need to be embedded in a membrane, whether it's the cell membrane of bacteria or the mitochondrial membrane? Remember, this membrane is working almost like a battery with these enzymes. It's trying to separate charges away from each other so that that energy can be produced. The more positives you have on one side of that membrane compared to the more negatives on the inside, that separation of charges produces more energy, more proton motive force, and it's that separation of charges that's going to give rise to the energy to power ATP synthase, and you can see that's where the bulk of this ATP is being produced. All right, I have this as H2O. Where did these initial hydrogens come from? Hopefully the fact that I have them in black, that was on purpose, makes you think back to pyruvic acid or even glycolysis when I have my entire glucose molecule. Just don't have it put together right now. Here's my pyruvic acid. What did we do? We harvested all of those hydrogen atoms, which every hydrogen atom is a proton and an electron. Why are we harvesting those? Because it's those protons and electrons that enter the electron transport chain or the energy market that will be transformed to produce ATP because they are able to generate that proton motive force. But those hydrogens, protons and electrons, do have to end up somewhere, and the somewhere is going to be on that final electron acceptor, which is oxygen. What if you had a toxin or a poison like carbon monoxide? So carbon monoxide is poison. will bind to one of these enzymes and prevent that enzyme from working. If one of those enzymes is inhibited, will that entire process stop? Yes. One of the reasons carbon monoxide can be poisonous to us. All right, I think I have gone through enough questions. Here are a couple more. Is there any carbon dioxide that goes into the electron transport chain? Nope. Carbon dioxide is a waste product of the Krebs cycle. Once it's produced, it is excreted. Is there any ATP that is put into the electron transport chain? No. The ATP is coming out of the electron transport chain. The only place that energy has to be invested is at the very beginning of glycolysis. Is oxygen being produced by the electron transport chain? Hopefully you are saying no. Oxygen is being input. It has to be provided to that electron transport chain, and it will come out of the electron transport chain as water. With those extra electrons, it has been reduced. All right, I think that is it.